Advanced Algebra Concept Exam Review. We're reviewing concepts 11 through 15. This first question just asks, what's the vertex of the function y equals the absolute value of x plus 6 minus 5? This one's set up real nice for us. The vertex is at -6. Notice we always take the opposite of this value, -6 comma -5. We take exactly that value. So the x value of the vertex comes from what we see in there, and the y value comes from what we see out here. So just as a reminder, the x value comes from the opposite of what we see in there, and the y value comes from what we see out there. If I wanted to check this, I could pick up my Inspire and I could just graph this, go into the scratch pad and do a quick graph of y equals absolute value of x plus 6 minus 5. Notice it's not going to graph as y equals, it's going to graph in my case as f1 of x equals, and that's okay. That's all I need, is I need a graph of the absolute value of x plus 6 minus 5. And I'm done. So my final answer is right here. My vertex is -6 comma -5. Number 2 asks me to graph y equals negative absolute value of x minus 3. In order to do that, I'm going to want to identify the vertex, which is at 3 comma 0. I know it's at 3 because the opposite of -3 is +3, and I know the 0 because there's nothing out here. So let's go ahead and plot that at 3, 0. Notice this is going by 2, so 2, 4, 6, 8, so 3 is going to be right here. And I need to note that this is going to open down because it's negative. So it's going to go down 1 and over 1. Down 1 and over 1 all the way down. Same thing on this side. Down 1 and over 1. Down 1 and over 1. Let's go ahead and draw those sides. And we've got that graphed. Again, if I wanted to check this, I could pop this into the Inspire and get a graph that would check that. Notice the vertex, the maximum value under the analyze. You can analyze these graphs and look for maxes and mins. This one has a maximum value at 3 comma 0, just like ours does. Also notice that it should have the same y-intercept, so we are good to go. Number 3 also asks us to graph an absolute value inequality, actually an absolute value equation. We need to identify the vertex. In this case, it's going to be at -2. Always take the opposite of what you see there, comma, and we see -3, so -2, -3. So let's go to -2 and to -3. Here's my vertex. This one's going to open up. It's got a positive absolute value, and it has a slope with sides of 1, so it's going to go up 1, over 1, all the way through here, and up 1, over 1, all the way through here. So let's go ahead and grab the line tool here and draw these lines. And again, if I want to check this, I can go ahead and put this into my Inspire and get a graph that I could use to check what I did in my work. Notice that the vertex, the minimum value of the graph, is at -2, -3, just like the vertex we calculated. Number 4 asks us to solve a system, and we've learned that the easiest, most efficient, accurate way to solve systems is using matrices in the RREF function. So let's go ahead and do that. If we pick up a Inspire and we plug this in, we see that we get, we put in the 4, the 4, and the -20, the coefficients of the first equation at 4, 4, and -20. And then the coefficients in the next equation, the 7, the -3, and the -5. The resultant matrix shows that x is -2 and y is -3. So we'll go ahead and record our answer as x is -2 and y is -3. Notice that this has an x column, a y column, and a constant column. Our answer matrix has an x column, just like this does, in the same order, a y column, just like this does in the same order. X column, a y column, and it has an answer column. So basically 1x equals -2 and 1y equals -3. Just pairs right up. So we have a final solution here. This problem's a lot like the last one, except it doesn't give us the equations. We need to write those ourselves. So let's go through this. It says that 75 people attended a ball game. There are 4 times as many children as adults in the group. It says set up a system of equations that represents the number of children and adults who attended the game. So we have to do a system of equations, and we have to solve the system to find the number of children. So it's asking for us to do quite a bit here. If there are 75 people, some were children and some were adults, the number of adults, which I'm going to call A, plus the number of children, which I'll call C, has to be 75. That's a pretty straightforward question for us to find. The other question is the 4 times as many children as adults. I'd like to set up an equation that says that the children and adults are equal, but they're not equal. There's already way more children. There's 4 times as many children as adults. So if I wanted it to be the same number of adults, I'd have to multiply that by 4. So for example, if there were 10 adults, there would be 40 children, and 4 times 10 would be 40. So this works out. One of the easiest ways to solve this by hand is just to use substitution. C is equal to 4a, so let's go ahead and put 4a into this equation for C. So a plus 4a has to be 75. A plus 4a is 5a, has to be 75. And if we divide both sides by 5, a turns out to be 15. If there are 15 adults, there have to be 60 children, because 15 plus 60 would equal 75. And also 4 times 15 is 60. If I wanted to check this, I could rewrite this second equation. I could just subtract 4a from both sides and write it as -4a plus c equals 0. And that would give me a system of equations that I could put into my calculator and check. Notice that this says there are a is equal to 15 adults and c is equal to 60 children. So the calculator check agrees with the solution that we found. So 60 kids. Number 6 asks us to solve the system of inequalities, and what they mean by that in this context is just show the solution by graphing. So we've got y is less than or equal to -3x minus 2, which gives me a y-intercept at -2. And with a slope of -3, I'm going to have to drop 3 to run 1. So 1, 2, 3, and run 1. This goes through this point. Let's run that the other way. Let's go 3 and run to the left. 1, 2, 3, and run to the left. It gives me this point. Let's go ahead and draw that line in. And figure out shading. It says that y is less than. So if I put in 0 for x and y, I get 0 is less than -2, which is false. So it's actually going to shade the non-0, 0 side. Because we want always shade true sides, never false sides. And 0, 0 turned out to be false, so it's a false side. And then let's go ahead and graph the other line. It says that it has an intercept at -3, which is down here, and a slope of 4, so that rises 1, 2, 3, 4, and runs 1. Let's do that again. 1, 2, 3, 4, and runs 1. And we'll go ahead and graph that line. But this line's not solid. The first line was solid because it had or equal. This one can't be equal, so it's a dashed line. So we're going to draw that as a dashed line and figure out shading for it. If I plug in 0, 0, I get 0 is greater than -3. That's true, so the 0, 0 side of this line is the true side. We always shade true sides, never false sides. So the overlap is going to be in this area out here. Let's go ahead and shade that in. And there we have our solution. If we wanted, we could pick up a calculator and check that. And notice that we have the same solution, overlap in this area, and x and y intercepts all the same as what we found. This problem's a lot like the last one, except again they don't give us the equations. They give us a problem to pull equations out of. An exam consists of two sections. There's an x section and a y section. There can be a maximum of 95 questions. There must be at least 5 more questions in the y than in the x. We're supposed to do a couple things. We're supposed to write a system of inequalities to model the number of questions, and then we're supposed to graph the system. So let's start writing that system. If there can be a maximum of 95 questions, that means the number of x questions plus the number of y questions can't be more than 95. In other words, they must be less than or equal to 95. There must be at least 5 more questions in y than in x. So y is supposed to be larger than, so greater than or equal to x plus 5. And then it wouldn't make sense to have a negative number of questions, so x is greater than or equal to 0 and y is greater than or equal to 0. So this group of questions right here takes care of this first request, write a system. Now we just need to graph the system. And as I look at the graph that's provided for me here, I noticed that the y values are kind of inadequate. I'm not going to be able to get up to 95 very easy. So what I'm going to do is I'm going to just make a note here that we multiply all these by 10. So the 1 would be 10, and the 10 would be 100, the 6 would be 60, and so on. So we're just going to multiply all that by 10 so that this makes sense. To graph x plus y is less than or equal to 95, let's just find a couple points that work on that equation. If x is 0 and we're looking for equality, when we're finding points, we're always looking at the edge, the boundary of a graph. So we always look for equality. So when x is 0, y is 95. When y is 0, x is also 95. So we should have a point at 95, 0, 95, and another one at 95, 0. Let's go ahead and sketch that line in. Shading on this should be below. 0, 0 checks out, true. And then let's go ahead and sketch the other line. Actually, we can sketch this line a couple of ways. We could just use the intercept and the slope. The slope's going to be a little tough, but not so bad. Let's go ahead and use this method. If x is 0, y is 5, that's pretty easy. But if y is 0, x would have to be negative 5, which isn't going to fit on this graph too well. So let's just pick another value for x. Let's see what happens if x is 50. If x is 50, then y would be 55, because 50 plus 5 is 55. Let's use the first and the third point here to graph with, since they fit on this graph well. 0, 5 is about right here. And if we go to 50 and up to 55, we're about right here. And let's go ahead and graph that line. It looks like that intersection point is about 45, 50. Does that work in this one? 45, 50, yep. 45, that is 45, 50. It works in both these equations. So when x is 45, y is 50. It didn't ask us for that information, but since it fell out so nice on the graph, let's go ahead and just do it. We need to do shading here. Y is greater than x plus 5. If we put in 0, 0, it's false, so the 0, 0 side is false, the other side is true. And boy, that pen messed up pretty bad there. And we'll just show the shaded region in here. And that's it. They asked us to write a system. We did that here. They asked us to graph it. We did that here. If I wanted to, I could check this on an Inspire, and I also did that. And found the same intersection point on the Inspire. Our last question asks us to graph a system of constraints that's provided here, and then find the values of x and y that maximize the p equals 30x plus 10y. These first two, x is greater than or equal to 0 and y is greater than or equal to 0, just force us into the first quadrant, which is nice. This next equation, let's rewrite that. Let's divide everything by 2, so that would give us negative x plus y is less than or equal to 4. And let's just go ahead and add x to either side. So y is less than or equal to x plus 4. I think we can just graph that using the intercept and the slope. So the intercept is 4, which is right here. The slope is 1, so it's up 1 over 1, all the way out off the graph paper here. So let's go ahead and sketch that line in. And we've got y is less than, so if I put in 0, 0, 0 is less than 4 is true, so we're shading on the lower side of that line. And we have one more line to graph here. X is less than or equal to 2. Well, that should go through the x-axis at 2. So it should go through right here, and it's a vertical line. I missed by a hair. That's going through the vertical axis at 2. And we shade to the left on that one. So we've got this shaded region in here. Now we need to find some points. This looks like the point 2, 6. Does 2, 6 fit in here? 2, 6 fits in this equation. X is 2, so it fits in that equation. So we've got 2, 6 is the intersection point here. This point is 2, 0. The point in the corner is 0, 0, and the point at the top here is 0, 4. We need to plug those into the function and look for a maximum value. So the function is p is equal to 30x plus 10y. My points are 0, 0, 0, 4, 2, 6, and 2, 0. And notice that my function has everything positive, so I should be able to rule out some values here that I don't really need to plug in. Zeros are equal. 4 is bigger than 0, so 0, 4 is going to give me a larger value than 0, 0. 2 is bigger than 0, and 6 is bigger than 4, so 2, 6 is going to give me a larger value than 0, 4. My 2's are equal, and 6 is bigger than 0, so 2, 6 is going to give me a larger value than 2, 0. Let's go ahead and plug this in. 30 times 2 plus 10 times 6 is equal to 120. The question is, find the values of x and y. Well, the values are x equals 2 and y equals 6. The values of x and y that maximize the function. It gets maximized at the value 120, but that happens when x is 2 and y is 6. And that's it for this exam review.